Hello everyone. In this video, we will be discussing about finding the derivative of an exponential function. Now, the formula in finding the derivative of an exponential function, particularly a natural exponential function, is that we have here the derivative of e to the u with respect to x is equal to e to the u times the derivative of u with respect to x. Now, the derivative is just copying the original function e to the u and then deriving our exponent u. Our u here could be any function. It could be constant, linear, quadratic, radical, rational, or any function. Now, for example, if I have here y is equal to e to the x, we know that our u here will be equal to x. U is our exponent of the e, which is now representing the x based from the original problem. Now, in finding the derivative of u, denoted as du over dx, okay, the derivative of x is 1. So basically, in finding the derivative of y is equal to e to the x, we have here y prime. Y prime is the notation for the derivative of y, or you can use dy over dx. Then according to our formula, all you have to do is to copy the original exponential function. So you have e to the x and multiply that with the derivative of your u. In this case, the derivative of our u, which is x, is 1. So this is now times 1. Simplifying, e to the x times 1 is e to the x. This is now our derivative. Another example, if I have here f of x is equal to e raised to the power of 6x. As you notice, our y becomes f of x. Y and f of x are the same. Now at this point, what is our u, or our exponent of e? Our exponent of e is now 6x. All you have to do is to write 6x as your u, and then finding the derivative of your u with respect to x is equal to 6. This is constant times a function. Now in finding the derivative of f of x, this is now f prime of x. The notation in finding the derivative of your f of x, so this is now f prime of x. So according to our formula, just copy the exponential function e to the 6x. And then after copying that, you have to multiply with the derivative of your u, which is 6. This point, if you will try to simplify, you can write 6 first, the constant, followed by e to the 6x. This is now your derivative. Another example, if we have here a function y is equal to e raised to the power of 4x squared plus 2x. Okay, our u here is now equal to 4x squared plus 2x. So in finding the derivative of our u with respect to x, we will be following the sum rule, wherein we are going to get the derivative of every term of our function. So the derivative of the first term would be 8x, and the derivative of our second term is 2. So in finding our derivative, this is now y prime which is now equal to e, copying e to the u according to our formula. So we have here 4x squared plus 2x. And then at this point, we are going to multiply with our derivative, which is 8x plus 2. So we have here 8x plus 2. 8x plus 2 is the derivative of our exponent, 4x squared plus 2x. You can rewrite this. You can let 8x plus 2 be written first, or you can just take this as your answer. Others would actually distribute, okay, e raised to the power of 4x squared plus 2x to 8x, and then e raised to the power of 4x squared plus 2x to 2. So distributive property, you could also do that. But this is now already acceptable. Another example. If we have here f of x is equal to e raised to the power of 1 over x raised to the power of 2. Now from here, our u is now equal to 1 over x squared. Remember that our u is our exponent coming from the e function or exponential function. Now, you can use quotient rule in finding your derivative when it comes to the u. But in this case, you can let x squared to brought on the numerator part. So this is now u is equal to x raised to the power of negative 2. In this case, you will be using power rule. So in finding the derivative of your u with respect to x would be negative 2 x raised to the power of negative 3. Or you can say this is now negative 2 over x cubed in order to eliminate negative exponent. So in finding the derivative of our f of x, this is now equal to copy e raised to the power of 1 over x squared, multiply that with your derivative of the u, which is now negative 2 over x cubed. This is understandable that our e raised to the power of 1 over x squared has a denominator of 1. So you can multiply both numerator and both denominator. So we have here f prime of x is now equal to negative 2 e raised to the power of 1 over x squared all over x cubed. This is now your derivative. Another example. If you have here y is equal to 2x e raised to the power of 4x. Now as you notice, this is now product rule because we have two functions being multiplied. So you can use product rule, but of course in finding the derivative of e to the 4x, we will be using derivative of exponential function. Recalling product rule, in finding the derivative, all you have to do is to copy the first function, multiply that with the derivative of your second function, which is now e to the 4x times 4, plus copying the second function e to the 4x, and then multiply that with the derivative of 2x, which is 2. Simplifying, 2 times 4 or 2x times 4, this is now 8x e raised to the power of 4x plus 2 times e to the 4x, you can let the constant be written first before the exponential function. And then from here, others would actually factor out the common, which is 2 and e to the 4x. But in this case, you can just consider this one as your answer. Thank you for watching.